Welcome. Today we're diving into the world of version control systems, a fundamental tool for every programmer. Whether you're working solo or as part of a team, version control helps you manage changes to your code, track progress, and collaborate efficiently. Imagine being able to revisit any point in your project's history, recover lost work, or experiment without fear. That's the power of version control. In this video, we'll explore what version control systems are, why they matter, and how they shape modern software development. Let's get started by understanding the basics and setting the stage for deeper exploration. Version control is a system that records changes to files over time, allowing you to recall specific versions later. It's like having a time machine for your code. This means you can track every modification, see who made changes, and revert to previous versions if something goes wrong. Version control isn't just for code, it can manage documents, images, or any digital file. By keeping a detailed history, it brings order and accountability to your project. Next, let's look at why version control is so crucial in programming environments. Programmers, version control is indispensable. It prevents accidental loss of work, supports collaboration, and makes it easy to experiment with new ideas. Imagine working on a big project with several teammates. Without version control, keeping track of everyone's changes would be chaotic. With version control, you can merge contributions, resolve conflicts, and always know who did what. It also provides a safety net, letting you undo mistakes and recover previous version. Now, let's explore the two main types of version control systems. Centralized version control systems, or CVCS, use a single server to store all versions of a project. Developers connect to the central server to get the latest code or submit their changes. This approach makes it easy to manage permissions and monitor activity. However, if the server goes down, access to the project is lost until it's restored. Examples of centralized systems include Subversion, SVN, and Perforce. Next, we'll compare this with distributed version control systems. Distributed version control systems, or DVCS, take a different approach. Every developer has a complete copy of the project's history on their own computer. This means you can work offline, and if the main server fails, any copy can restore the project. Popular distributed systems include Git and Mercurial. DVCS offers greater flexibility, resilience, and supports open-source collaboration. Let's now see how these systems actually track changes in your file. Version control systems track changes by recording snapshots of your files. Each time you save your work, the system notes what changed, who made the change, and when. This creates a detailed timeline of your project's evolution. If you need to review or revert a change, you can easily do so. This tracking is essential for debugging, auditing, and understanding how your project has grown over time. Next, let's talk about the concept of commits. Commit is like taking a snapshot of your project at a specific moment. When you commit, you save your changes along with a message describing what you did. This message helps you and your team understand the purpose of each change. Commits are the building blocks of your project's history, making it easy to revisit or undo changes. Let's see how branches fit into this picture. Branching allows you to create separate lines of development within your project. Think of it as working on a copy of your code so you can experiment or develop new features without affecting the main project. Once you're happy with your changes, you can merge your branch back into the main codebase. Branching is powerful for collaboration and innovation. Next, let's discuss merging and how it brings everything together. Merging is the process of combining changes from different branches into one. It's how teams bring together everyone's work into a single, unified project. Most version control systems help you handle conflicts that might arise when two people change the same part of the code. Merging ensures that everyone's contributions are included and the project moves forward smoothly. Now, let's look at how version control supports collaboration. Version control systems are designed for teamwork. They let multiple people work on the same project without overriding each other's work. Features like branching, merging, and tracking changes make collaboration smooth and efficient. You can review each other's code, suggest improvements, and keep everyone on the same page. This is especially important for remote teams or open-source projects. Next, let's see how version control helps with project management. Version control, managing a project becomes much easier. You can assign tasks, track progress, and set milestones. The detailed history helps you monitor who did what and when, making it simple to review work and ensure accountability. If something goes wrong, you can quickly identify the issue and fix it. Version control also supports agile workflows and continuous integration. Now, let's explore some popular version control systems. It is the most widely used distributed version control system today. It's fast, flexible, and supports both small and large projects. Git allows you to work offline, create branches, and merge changes with ease. Its popularity has led to a huge ecosystem of tools and services like GitHub and GitLab, which make collaboration even easier. Next, let's briefly look at other systems like Subversion and Mercurial. Subversion, or SVN, is a centralized version control system known for its simplicity and reliability. It's often used in enterprise environments. Mercurial is another distributed system, similar to Git but with a focus on simplicity and performance. Each system has its strengths, and the best choice depends on your project's needs. Now, let's talk about how to get started with version control. Start using version control, you'll need to choose a system and install the necessary software. For Git, you can download it from the official website and set it up on your computer. Most systems offer graphical interfaces as well as command line tools. Once installed, you can create a new repository, add your files, and make your first commit. Let's walk through the basic workflow next. Basic workflow in version control involves adding files to your repository, making changes, and committing those changes with a message. You can create branches to work on new features, merge them when ready, and push your changes to a remote server for backup or collaboration. This cycle repeats as your project evolves. Next, let's discuss the importance of commit messages. Good commit message clearly explains what you changed and why. This helps your team understand the project's history and makes it easier to review or debug code later. Keep messages concise but informative. For example, instead of just writing "fix bug," specify which bug and how you fixed it. Clear messages improve communication and project quality. Now let's look at how to handle conflicts. Conflicts happen when two people change the same part of a file. Most version control systems will alert you and help you resolve these conflicts. You'll need to review the changes and decide which version to keep. Good communication and clear commit messages make resolving conflicts easier. Once resolved, you can continue working as usual. Next, let's discuss the importance of backups. Version control systems act as a backup for your project. By pushing your changes to a remote server, you ensure that your work is safe even if your computer fails. If you accidentally delete something, you can recover it from the project's history. This peace of mind is one of the biggest benefits of using version control. Next, let's look at how version control supports experimentation. With version control, you can try out new ideas without risking your main project. Create a branch, experiment as much as you want, and if things don't work out, simply delete the branch. Your main code remains untouched. This encourages innovation and learning. Now let's talk about reviewing code with version control. Version control makes it easy to review code. Team members can look at each other's changes, suggest improvements, and catch bugs before they reach the main project. This process improves code quality and helps everyone learn from each other. Many systems offer tools for code review, making feedback quick and organized. Next, let's see how version control integrates with other tools. Modern version control systems integrate with a variety of tools, such as project management platforms, continuous integration services, and deployment pipelines. This integration streamlines your workflow, automates repetitive tasks, and ensures that your code is always tested and ready for release. Let's now discuss the importance of documentation in version control. Documentation is essential for any project. Version control helps you keep your documentation up to date alongside your code. You can track changes to documentation, review edits, and ensure that everyone has access to the latest information. This makes onboarding new team members easier and keeps your project organized. Next, let's look at tagging and releases. Tagging allows you to mark important points in your project's history, such as releases or milestones. This makes it easy to find stable versions, roll back if needed, or share specific versions with others. Tags are especially useful for managing software releases and ensuring consistency across environments. Now let's discuss access control and security. Version control systems offer robust access control features. You can set permissions to control who can view, edit, or manage your project. This protects sensitive information and ensures that only authorized users can make changes. Security is a top priority, especially for large teams or open-source projects. Next, let's look at auditing and accountability. Every change in a version control system is recorded, creating a transparent history of your project. This makes it easy to audit who made changes when and why. Accountability is built in, which is important for compliance, quality assurance, and team trust. If issues arise, you can quickly trace their source. Now let's talk about performance and scalability. Modern version control systems are designed to handle projects of any size, from small scripts to massive codebases. They optimize performance by storing data efficiently and supporting fast operations, even as your project grows. Scalability ensures that your tools won't slow you down no matter how big your team or codebase becomes. Next, let's look at some best practices for using version control. Get the most out of version control, follow some best practices. Commit often, write clear messages, use branches for new features, and regularly merge changes. Keep your repository organized and avoid committing sensitive information. These habits help your team work efficiently and avoid common pitfalls. Let's dive deeper into each best practice, starting with frequent commits. Frequent commits make it easier to track changes and isolate issues. By saving your work regularly, you reduce the risk of losing progress and make it easier to review your project's history. Small, focused commits are easier to understand and manage. Next, let's discuss the importance of using branches. Branches let you work on new features, bug fixes, or experiments without affecting the main code. Use them to keep your work organized and avoid conflicts. When a feature is ready, merge it back into the main branch. This keeps your project stable and encourages collaboration. Now let's talk about merging regularly. Regularly merging changes from different branches keeps your project up to date and reduces the chance of conflicts. It's easier to resolve small differences than large ones. Make merging a routine part of your workflow to keep everyone's work aligned. Next, let's discuss keeping your repository clean. A clean repository is easier to navigate and maintain. Remove unnecessary files, organize your folders, and use clear naming conventions. This helps your team find what they need quickly and keeps your project professional. Next, let's talk about avoiding sensitive data in your commits. Never commit passwords, API keys, or other sensitive information to your repository. Use environment variables or configuration files that are excluded from version control. This protects your project and your users from security risks. Next, let's discuss reviewing your history regularly. Regularly reviewing your project's history helps you spot issues early and understand how your code has evolved. Use version control tools to browse commits, compare changes, and learn from past decisions. This habit improves code quality and team learning. Next, let's talk about using tags for releases. Use tags to mark release points in your project. This makes it easy to find stable versions and share them with users or teammates. Clear tagging helps with deployment, troubleshooting, and documentation. Now let's discuss automating your workflow. Automation can save time and reduce errors. Use scripts and tools to automate testing, building, and deployment. Many version control systems integrate with continuous integration and deployment services. Automation ensures that your code is always tested and ready for release. Next, let's talk about learning from mistakes. Mistakes happen, but version control makes it easy to recover and learn. Use your project's history to analyze what went wrong and how to avoid similar issues in the future. Encourage a culture of learning and improvement within your team. Now, let's discuss the role of version control in open source projects. Version control is the backbone of open source development. It allows contributors from around the world to work together, propose changes, and review each other's work. Platforms like GitHub make it easy to manage contributions, track issues, and build communities. Next, let's look at how version control supports remote work. Remote work is more common than ever, and version control makes it possible. Teams can collaborate from anywhere, share updates instantly, and keep projects moving forward. Tools for code review, issue tracking, and communication are often built in. This flexibility is essential in today's workplace. Next, let's discuss continuous integration. Continuous integration, or CI, is a practice where code changes are automatically tested and merged into the main project. Version control systems make CI possible by providing a reliable way to track and integrate changes. CI improves code quality, catches bugs early, and speeds up development. Now let's talk about continuous deployment. Continuous deployment, or CD, takes CI a step further by automatically releasing tested code to users. Version control ensures that only approved changes are deployed, reducing the risk of errors. CD enables faster delivery of features and fixes, keeping your project agile and responsive. Next, let's discuss the future of version control. Version control systems continue to evolve, with new features and integrations making them even more powerful. Cloud-based solutions, better collaboration tools, and smarter automation are shaping the future. As software development grows more complex, version control will remain a cornerstone of successful projects. Now let's summarize what we've learned. We've covered the essentials of version control systems, what they are, why they matter, and how they support programming. From tracking changes and enabling collaboration to supporting automation and remote work, version control is an indispensable tool for developers. By following best practices and leveraging modern tools, you can keep your projects organized, secure, and efficient. Let's wrap up with some final thoughts. Version control is more than just a technical tool. It's a way to work smarter, collaborate better, and build stronger projects. Whether you're a beginner or an experienced developer, mastering version control will make you more effective and confident in your work. Keep exploring, practicing, and applying these concepts to your own projects. Thanks for joining this journey into version control systems. If you want to learn more, there are plenty of resources available. Check out official documentation, online tutorials, and community forums for your chosen version control system. Practice by starting your own project or contributing to open source. The more you use version control, the more comfortable and skilled you'll become. Happy coding! Thank you for watching this comprehensive guide on version control systems in programming. We hope you found it helpful and inspiring. Remember, version control is your ally in building, managing, and sharing great software. Keep coding, keep learning, and make the most of these powerful tools. Goodbye and best of luck on your programming journey.